The one problem that that I was not on my original list of things to do was that problem where we had find the probability that exactly so many things happened. There is problems like that are on the test, so you were asking about it. Now you won't have to do the entire, calculate out the whole table. So that was like page 241, number 1 down there, where we were figuring out the probability of having exactly X of those values. I won't make you do the entire table like that kind of problem, but finding the probability that there's exactly 7 out of the 8 deaths occurred before Thanksgiving, that type of problem can show up on the test, but not making the entire distribution won't. Questions on that? Okay. In that case, we were ready on page 383. Number 8 was the one I was wanting to start with. So on page 383, the sample size, you've been hired by a consortium of local car dealers to conduct a survey about the purchases of new and used cars. If you want to estimate the percentage of car owners in your state who purchase new cars, not used, how many adults must you survey if you want 95% confidence that your sample percentage is in error by no more than 4 percentage points? So I'm wanting to find the sample size. So obviously we're going to go to the little part on the table that says sample size. What am I looking for a sample size on? Proportion or mean? Okay, I'm wanting to know the proportion. Do I know p hat and q hat? Do I have a good idea of what I expect the sample proportion to be? Okay. I have no guess as far as what we have as the proportion of people that have bought new cars. And so if I don't know p hat and q hat, I got to go with the worst case scenario, which is that they're going to multiply to be 0.25. What will z of alpha over 2 be in this problem? I want to be 95% confident. Be the 1.96 because it's the alpha over 2, so you're taking that 0.95 or 0.05 and cutting it into 2 to get your 2 different tails. So that'll be your 1.96. Square that value, don't forget to square it, times the 0.25. What is E? Okay, it's my margin of error, and I want to be wrong by no more than 4%, so as a decimal, it's the 0.04. And again, don't forget to square that. Now, I told you I won't try to trick you up with rounding errors, and I'll just go ahead and do the calculations for you. When you do the calculations on this one, you get 600.25. This is one case where the rounding rule I want you to know. If it's sample size, which sample size do I need? Okay, 601. Now, always with sample size, always round up. That is one place that I don't remember for sure, but I think I might have the rounding rule actually come into play, that you have to be able to use that correctly. That I might actually have 600, 600.25, and 601 as your 3 choices, well, 3 out of your 4 choices, to where you have to realize that rounding up is important. And then maybe like 602, just to make it not obvious which one of the answers it is. I really don't remember what I have as my multiple choice answers. But things where the rounding rule is something you might need to know is going to be important on that one. Now, if you had known, and I think that's what part B is going to ask. Actually, part B doesn't. If you want to estimate the mean amount, of money spent by car owners on their last car purchase, how many car owners must you survey if you want 95% confidence that your sample mean is in error by no more than $750? Based on the results from a pilot survey, assume that the standard deviation of amounts spent on car purchases is $14,227. So now if I'm still going back to sample size, this time we're doing it for a mean. Notice you do everything first, then square the answer. What is z of alpha over 2? Okay, still the 1.96. What is sigma? It's my standard deviation of the population, which is? Okay, that's at $14,000. And what is our E? We're going to be wrong by no more than? That was on A. On B, part B? Okay, no more than $750. So do the arithmetic first, and then square it. So you're going to multiply and divide, and then square it. You get 1,382.3, which means what is my sample size? Okay, 1,383 people. Then on part C, if you plan to obtain the estimates described in parts A and B with a single survey, having several questions, how many people should you survey? So if part A needed 601 people and part B needed 1,383 people, how many need to be in my survey? Okay, that big number. You don't have to add them together because you've already got the 601 covered when you do the 1,300 people. So you don't have to have more than the 1,383, but you do have to have that many of them. And that way you can answer both questions at once. Okay, if we look at number 9 on this page. Listed below are weights in pounds of glass discarded in 1 week by randomly selected households. What's the best point estimate of the weight of glass discarded by all the households in 1 week? So how could I find it? I'm not going to make you do it, but how would I find the best point estimate of these values? Okay, best point estimate is going to be the mean. So my best guess of what things are going to be is going to start off just being that mean. If I want to construct a 95% confidence interval estimate of the mean weight of glass discarded by all the households. Grab my calculator out. So we found the confidence interval 2 different ways. One option is to go to the tables and do the confidence interval. And which one am I doing? A proportion, a mean, or a variance? No. Okay, this would be a mean. Do I know the standard deviation of the population or not? Okay, it does not give me the standard deviation of the population, so since I don't know that, then that means we're doing which one, the Z or the T scores? Okay, it means we're doing the T. Now, if I was doing this one, I would use our calculators. Ooh, that's really close. So putting that in as my list 1. From there, if I'm wanting to do a confidence interval, and we know we're going to use our T scores, when we go to stat, go to test, where do we go next? T interval, because we're finding a confidence interval, so we're using the one that has interval in it, and it's using the T score to do it. So you're doing your T interval. Usually we go from statistics. This time I'm taking it from my data. And do we want to be 95% confident? And it gives us that confidence interval. That doesn't look right. I must have put a number in wrong. Yep, I definitely put a number in wrong. That looks better. So then we're looking at having that interval of the 1.786 to 5.894. So it's telling us what we would have as our interval in this case. Questions there? Now, you could have gone and used your table. If I was using my table, I guess one thing I should mention on this one, if we're doing our t-scores to find the t of alpha over 2, what would I have used for the degrees of freedom? Okay, you're going to do n minus 1, so we had 1, 2, 3, 4, 5, 6, 7, 8 of them in there, so we have a degree of freedom of 7. And when we have that degree of freedom of 7, we want it to be 95% confident. So my area in my two tails would be the 5%. And so you'd be using the 2.365 as your t-score. And you would have to calculate out your standard deviation on this problem, so it's easier just to use the calculator anyhow for this problem. Now, in part B, part C, repeat part B, assuming that the population is normally distributed with a standard deviation known to be 3.108. So if I know my population standard deviation, what has just changed? Okay, we've changed it to using our z-scores. And so what changes on our calculator? I'm going to go to stat, or over to test, and go to which one? Okay, this time we're doing our z interval. And then it's going to come from the data. And then it can, I think I hit things. Oh, that would make a difference now, wouldn't it? How do I put the standard deviation in a B to 3.108? Thanks. And so it changes it slightly, not an extreme change. Instead of being 1.786, it's 1.686. And instead of being 5.894, it's 5.994. So it's changed your value some, your interval some, but not huge amounts usually when you do that. Yes? Uh-huh. Is it letting you plug in 1? Because I've tried to do that in the past and it doesn't like it. I agree that that's the problem, and I don't know why it's... Huh. Okay. Well, I'm glad you figured out the trick around that. Because I knew it needed to be 1, and that's why I've always had to make you make a list of 1s, because it needed just to be... But yeah. Well, it was 2 weeks ago is when we put in a second list, and we needed both of them, and it just didn't like it after that. I don't know. It's weird. Okay, questions on that one? If we look at number 10 on this section, number 10 is where we couldn't use a calculator shortcut. Use the sample data from exercise 9 to construct a 95% confidence interval estimate of the population standard deviation. So if I'm wanting to find a confidence interval for the standard deviation, now all my chart gives me is the confidence interval for variance. How does variance relate to standard deviation? Square root. So we just have to take the square root of the variance, and then that'll give us our standard deviation. So if I'm trying to do the variance, or standard deviation, we'll take the square root of all this, but I have to use my chi-squared values. So as I'm doing this one, actually first, I will give you the standard deviation. You would have to use a calculator to grab the standard deviation on this one, which, just as a reminder, where would the standard deviation be hiding in this? Okay, stat, calculate one variable statistics. And it comes from that list 1. So my standard deviation is the 2.4568, so 2.457. What will be my chi-squared values, though? So first of all, what is my degrees of freedom? Okay, we had 8 values. We got degree of freedom of 7. We want to be 95% confident. So what would be my chi-squared values? Okay, 0.95 is getting cut in half. So one of them is 1.690. The other one is the 16.013. So you've got your chi-squared on the left, your chi-squared on the right. Because you're going to have 2 different values when you go to do that. So you're looking at taking, so we are, sorry, I didn't write this real neat because this is my notes for myself. But you'll take that 7, which is your n minus 1. Here's your 7. Your s, we just found on the calculator, to be the 2.4569. Squaring that value, because that'll turn into your variance, divided by, this is your chi-squared on the right, which is your larger number, which is the 16.013. Your standard deviation is between those, and then you'll have the square root of the 7 times the 2.4569 squared divided by the chi-squared on the right, which is the 1.690. Again, be careful with your order of operations as you plug things in the calculator. And you get an answer of being between 1.624 to 5. Now, if I wanted the variance, I would have done that before I square rooted them. I would have just taken those numbers. But that was the one we could not use the calculators to be able to have a shortcut on. Questions? I guess I'm flying through this. I should slow down a little bit. Questions on those? Uh-huh. It's actually organized. But I don't have it listed of, hey, this is chapter 2 and this is chapter 3, but I left it pretty much in order. It may not be exact, but it's pretty much in order. Other questions so far? Okay, if we look at page 452. So that was looking at finding my confidence intervals of I am 95% confident the values are between. So for that chi-squared value, I am 95% confident that my standard deviation was between 1.624 and 5.0. So we were showing that confidence of where we knew it was somewhere in this range. Now your hypothesis testing is doing the others. We're saying we think we know what it is. Are we right? And so then we're testing to see if we've got a good hypothesis on these or not. So if we look at page 452 and look at number 1, it's looking at the rate of smoking. A simple random sample of 1,088 adults between the ages of 18 and 44 is conducted. It is found that 261 of the 1,088 adults smoke. Use a 0.05 significance level to test the claim that less than 1/4 of such adults smoke. So first of all, what is my null hypothesis? Okay. What equals 1/4? Okay, that P is going to equal 1/4. What's my alternative hypothesis? No. It's not the way this one's claimed. Okay, so it's claiming that less than 1/4 of adults smoke. Now that I have what my null hypothesis and my claim are, and we know alpha is 0.05 in this case, it's given to us. If we're doing our test statistic, are we doing a test statistic for a proportion, or a mean, or a standard deviation? Since we're doing it for a proportion, that means we're going to have to use the z-score as our test statistic. What is p hat? How do I find p hat? Okay, 261 divided by the 1088. What is p? That's what we're claiming to be true, which was the 1/4. So p is still 1/4. Q is, and we had 1088 in our sample. So I get negative 0.77. Now, we had two different ways we can go about figuring out what to do with that. We can either find the p-value or we can find the critical value. If I was doing it by hand, critical value is easier. If I wanted the critical value to be 95% confident, are we doing a left-tailed, a right-tailed, or a two-tailed test? Okay, why is it left-tailed? Okay, because we're talking about having our alternative is that it's less than. So since my alternative is less than, then that's telling me I'm doing a left-tailed test. If I'm doing a left-tailed test and we had a z-score, are we going to look at our negative z-scores or our positive z-scores? So we're on the negative. What am I looking for right now? I'm looking for the stuff inside the body of the table. Do I want the 0.05 or do I want the 0.025? Why 05? Okay, it's all in that left tail. We're not worrying about what's going on in that right tail. So if we're doing the 0.05, oops, down here at the very bottom of the negative 1.645 is my critical value. So we're saying we have normal distribution. We want all 5% in this left tail, which is going to be that negative 1.645 is my critical value. We had negative 0.77. So is that a reject or a fail to reject? Okay, this one's going to be a fail to reject. So I'm failing to reject this original hypothesis that the proportion equals 1/4. And I don't remember that the wording comes into play on any of these. I don't think I have that. But this is where original claim did not include equals. We failed to reject. So there's not sufficient evidence to warrant rejection of the claim that the proportion was less than 1/4. Questions? Okay, if we looked at, let's finish that one the other way too. What if I wanted to find the p-value? So I had z equaling negative 0.77. What if I asked you to find the p-value? First off, again, is this a left-tailed, a right-tailed, or a two-tailed test? Okay, we're still on our left-tailed test. So I'm wanting the p-value being the probability that it's on that side, that you're getting a value at negative 0.77 or less. How am I going to find my p-value? What would I look up on my table? Am I looking at things inside the body or am I looking at the z-scores? Okay, I know the z-score. I know the z-score is the negative 0.77, so I'm going to find my negative 0.77 as my z-score. And this is going to give me my p-value being my area to the left. It is. Which gives me that 0.2206. So my p-value is the 0.2206. 22% chance that it's going to happen like that just by random chance. Now, how would we have used our calculators to have done this problem? Go to stats, go to tests. Which one are we going to do? Okay, one proportion z-test. I want to do a test. I'm testing that hypothesis. We're doing a proportion, and we only have one proportion that we're looking at. We're not trying to compare if I knew the probability of smokers and the probability that they lived in Trenton or something like that. I'm not trying to compare two different things going at the same time. Now, what is P naught? Okay, that's what we are saying is true in our null hypothesis, is that we think it's 1/4. X, the number that satisfies that. N is the number in our sample. We were doing a less than, so we would calculate that out. Now, notice my p-value gives me that same thing at 0.2206 that we found just a moment ago. It's giving me my test statistic at negative 0.77 that we found a little bit ago. Questions there? No. Each problem is separate. 40 questions. 40 multiple choice questions. So the right answers are there somewhere. Some of the most common wrong answers are also there somewhere. Back on this problem, what if I changed this problem to my null hypothesis was that P was equaling 1/4 with the alternative that P did not equal 1/4? So that's not going to change my test statistic of negative 0.77. There's nothing about that that's going to change. But it does change my critical value, and it does change my p-value. What's that do, first of all, if I wanted to find my critical value? If I wanted to find my critical value, I'm still using alpha as the 0.05. Okay, so now it's a two-tailed test, and so I'm going to have 0.025 in this tail. I'm going to have 0.025 in this tail, which means I'm using what? What would you say? Oh, look up 0.975 and look up 0.025, which are going to give you what? Our oh so familiar numbers of 1.96 and negative 1.96. Now don't count on everything having alpha being 0.05. I know I have some different critical values, or different alpha values, significant values, so you won't have it that's always just count on it being the 1.645 or the 1.96, because I know at least one question I got alpha being 0.9 and different things in there, so you will have to be able to read the tables. Now, those are my critical values, so still this is going to be a fail to reject, because obviously negative 0.77 is not going to be in that region. If I wanted to find my p-value without the calculator, because it's a two-tailed test, once I found, we said that z equaled negative 0.77, we already found the p-value to the left of that to be 0.2206. But if it's a two-tailed test, what do we have to do? Okay, I got to double it because whatever we'd have over here on the right tail, we'd have to do also. So my p-value has to be twice that. We would take the 2 times the 0.2206 to get 0.4412. If we were doing this one as a two-tailed test instead, you'd have to find that p-value that we had to the left and double it because we rejected if it was too far to the left or too far to the right. Now, granted, if we were doing the two-tailed test on the calculator, pretty quickly to go doing the stat tests, still doing the one proportion z-test. The only thing we changed was that it's not equal to now. And we can see that we just doubled our p-value to get that 0.4412. Questions there? Okay, if we look at one where we don't get to use the calculator shortcuts on number 10, just change to a different problem here somewhere. Number 10 on the top of page 452. No, that's not the right one either. Number 10 at the top of page 453 is the one I want to look at. The weights of cars. A simple random sample of 32 cars yields a mean weight of 3,605.3 pounds, a standard deviation of 501.7 pounds, and the sample weights appear to be from a normally distributed population. Use a 0.01 significance level to test the claim that the standard deviation of the weights of cars is less than 520 pounds. So where do I start? Okay, I know I'm going to be using a chi-square. Before I even do that, though, what's h naught? I'm on page 453, number 10. I had a hard time finding the right number 10 also. Okay, what are we going to compare to 520? Not less than, not for the h naught. Okay, standard deviation equals the 520. Make sure you do pay attention to whether it's standard deviation, proportion, or mean that we're working with. What is my alternative? Okay. So now we know we're doing our chi-squared distribution, because we're comparing standard deviation. So since we're trying to do a test with the chi-squared, we're doing the chi-squared is the sample size minus 1 times the variance of the sample over the variance of the population, which those two key pieces of information was given to us in the problem. We're taking the 31 times the 501.7 squared divided by the 520 squared to get 20.86. So this would be my test statistic, is the 28.86. Now, is this one a left-tailed, a right-tailed, or a two-tailed test? Okay, we're doing a left-tailed test. We know with our chi-squared, it's skewed to the right. So it continues on for a while. I need to find my critical value first. So for my chi-squared table, what am I using as my degrees of freedom? Not 40. 30, because it's 31 would be what we would use, but 30 is as close as we can get. since we're doing a left-tailed, do I want the stuff on the left side or do I want the stuff on the right side? So we're doing this left side. What's my alpha in this case? Okay, alpha is going to be your 0.01 this time because we're doing the 0.01 significance level. So all 0.01 of it's going to be in this left tail, so you're looking at the 0.99. So when we go to the 0.99, we're finding our critical value to be 14.9454. Which is telling me if I get 14.954, anything from there or to the left is going to have that 0.01 as my area to the left. Well, 28.86 is over here. So is that a reject or a fail to reject? This is back to being another fail to reject. I will not ask you from the chi-squared to try to predict a probability. Because that's just not an easy thing. If you're just, because all you can do on those is say, well, it's somewhere between here and here, or something less than this. Trying to find the p-value is not very easy from the chi-square distributions. Questions there? Okay. If we look at the final one from chapter 10. We look at page 578. No, that's the wrong page, sorry. Let's look at page 577. So if we look at number 3 on page 577, the length and weight. Listed below are the body lengths in inches and weights in pounds of randomly selected bears. If we find the correlation coefficient and find the best fit line, or the regression equation, so parts B and C, where do I start if I wanted to find the correlation coefficient or the regression line? What do I do with the length and weight? This would definitely be a use our calculator thing. These are the ones that I forced you to do by hand that took the front page of the last test. So I'm not going to make you do it by hand. How do I use the calculator? Okay, go ahead and put that in list 1 and list 2. So we're getting our data in there. After I have my data into list 1 and list 2, where do I go next? Stats, calculate number 4, the linear regressions. As long as you put it in list 1 and list 2, you can just hit enter. If you put it somewhere else, tell it where it was. Now, what's my correlation coefficient? That's my R, so that's the 0.964 this time. What would be my regression equation? And usually when we see them in stats, we do them the opposite way, where we put the y-intercept first. We'd usually write that y equals negative 467.8 plus, and then put your slope 12.29x. Count for it? No. No. And that's one of those just little differences between, because with statistics, usually you're doing it more of an application kind of problem. And if you're applying something, you know where you're starting at, and so you tell where your starting point is, and then how do you get to the next point, which is what your slope does for you. Because in word problems, the y-intercept has a very important meaning as your starting point. And for some reason, in college algebra, we put the slope first. Because a lot of times the slope has a lot of meanings in college algebra as far as application type things. This is just a matching. You have to figure out which way I wrote it to match it up. So there won't be a question. I won't put them two different directions on you. Now, in this problem, is this correlation coefficient good enough? Is there a correlation between these or not? So as we're looking at our table, what would we use for n? Okay, we have 5 points. So if we were at alpha being our significance level, it's 0.878. If it's 1% significance level, so 0.01, it's the 0.959. Either way, is 0.964 good enough? Okay, they're both good enough. They're both, because our correlation coefficient is better than our critical value. So does that tell me there is a correlation or there is not a correlation? There is a correlation. So there seems to be a relationship then between the length of a bear and the weight of a bear. Kind of what we would anticipate, that there would be a correlation between those, but sometimes those things don't necessarily match. Questions there? Now we should have looked at our scatter plot. Here's our, oh, you can't see that. There's the scatter plot. You can see there's kind of a linear correlation. Honestly, exponential equation might be a better fit to this one. So it's not a great straight line that would go through those. Definitely trying to look at it with more bears is a better plan to look at stuff. It's harder to predict with fewer points, which is the reason why that you have to have such a better correlation. That's why these numbers have to be so much. Whoop, wrong direction. When you have the smaller sample size, these correlations have to be a lot closer to 1 to really say there is a correlation. As you get more, if this case, if we had a sample of 20 bears instead, we wouldn't have to have nearly as good a correlation to really say that there is a relationship between those two things. It wouldn't have to be as high of a strong of a number, I guess I should say, to say there's still a good correlation. So if I wanted to predict the weight of a bear that's, what's a good, let's go with 50, whatever we're using for length, whatever units they were looking at. Oh, based on the given sample data, what's the best predicted weight of a bear that with a length of 72 inches? So part D is looking at it for 72 inches. Oh, my line equation just went away. So we would use our equation. So we have the negative 467.76 plus the 12.286 times the 72 inches. And so we would expect it to be 417 pounds. Now this one's going to have a little bit different because I rounded quite a bit. I probably should have kept more decimals. Because when they did it, they had 418 pounds. So I have a little bit of rounding error going on. Questions there? And then that last section we did was section 11.3. Trying to jump to different ones that you guys haven't seen already before. Well, let's look at the one on page 620. Let's look at lightning deaths. Actually, I don't want to do lightning deaths. That's not quite what we've been doing. I don't have any good examples that I really like. I guess do number 1. Bottom page 619 that goes to the tables at the top of 620. Testing for adverse reactions. The table on the next page summarizes results from a clinical trial. Use a 0.05 significance level to test the claim that experiencing nausea is independent of whether a subject is treated with Celebrex, ibuprofen, or a placebo. Does the adverse reaction of nausea appear to be about the same for the different treatments? So if we have our 3 different treatments, and whether we have nausea or we don't have nausea, where do we go with this? Okay, we're going to do our matrix. We're going to edit our matrix. Size of this one is a 2 by 3. Putting your information in. And notice as we're doing this one, we're not trying to say that, we're not getting real specific that the Celebrex causes less nausea than ibuprofen or something along this line. What we're just trying to say is there a relationship between whether you have nausea and what type of medicine that you take? We can definitely see that they gave a lot more of the Celebrex than what they did ibuprofen, compared to what they would give the placebo had fewer than the Celebrex. So you can't just say that because there was more people that had didn't have nausea or more people had nausea that took Celebrex. Well, there's just a lot more people that took Celebrex. And so that's what we're trying to look for. Is there a correlation between these two things? So now, once I have that in there, where do I go? What do I do with it from here? Stat, tests. Okay, looked at C, which is your chi-squared test. It was observed. We put it in matrix A, telling it where to put it, which is matrix B, and we let it calculate it. So we get a chi-squared value of 9.29 with a p-value of 0.00958. So p-value of 0.01. So my p-value is just a little bit below the 0.01. We're using a 0.05 significance level. So is that a reject or a fail to reject? This is going to be reject our null hypothesis, which what was the null hypothesis? These kind of tests, the null hypothesis is always a test of independence. So we're assuming it's independent. We are rejecting that, which tells me what? Tells me that they are dependent. So this says that the adverse reaction of nausea does not seem to be the same for the different types of treatment. So that the nausea does change based on the type of treatment. Questions? Okay, our test is on Friday at noon. I won't be here to do anything with you guys on Wednesday, so don't show up Wednesday. So Friday at noon, you get to take your stats test. Make sure you bring your pencil, your calculators, and a Scantron. Have I told you guys about Scantrons? Okay, if you guys would please get a Scantron. Bookstore for 20 cents. I think they went up last year. I know. It's a whole 10 cents now.